room. Okay, so today we're going to keep practicing with our tens and ones class, and hopefully you were able to cut a bunch of them yesterday and you have some ones and tens and hundreds. Okay, all right, now first let's go over the names. These little cubes are ones, and we could call them ones. We could call them cubes. And our book this year is going to call them single blocks. Single blocks. And you'll see that when we get to our book today. Okay? Single blocks. So those would be ones. Okay? And the way that we're going to draw them when we draw them is we're going to draw it with a little tiny circle like that. Okay? That would be in the ones place. All right. And then tens, or I sometimes call them rods, but our book calls them stacks. Okay, so it's kind of like a new vocabulary that we have to get used to, but you probably remember this from last year. Okay, so, and the way that they draw it in our book, if we're doing a quick draw, is just a line. It almost looks like a tally mark. It's just a line. Okay, and then our hundreds, they're worth hundreds, so this would be our hundreds column. Our hundreds, I sometimes call a flat. And in our book, they call them a box. Okay? And, or boxes, I guess, because I've made all the other ones plural, so I'll make that one plural. They call them boxes. And the way that we're going to draw it is with a square. Okay? So a square for 100, a line for a 10, and a circle for a 1. Okay, and let's review the vocabulary again. Ready? A circle would be a single block, a line would be a stack, and a square would be a box. Okay? All right, so we're going to take that vocabulary and we're going to start making some numbers. Okay? Just like you did yesterday, you practiced making them yesterday, but if I asked you to say, let's make the number, here, okay, let's make the number 15. You can make the number 15 with 1, 10, and 5 ones, right? 1, 10, and 5 ones, 15. Is there another way I can make the number 15? Well, sure. I could take the stack away, and if I take the tens away, if I take one stack away, how many single cubes do I need to add? To add 10 single cubes. Okay, so I still have 15, it just looks different, and that's what we're going to practice with today. Okay, we're going to practice with making those trades that make the numbers look different. We can build them differently, but they're still exactly the same number. Okay, let's do one other quick one together. Okay, let's say that I have a flat, they call it a box. I have three stacks, and I have one single cube. What's my number? My number is 131. 100, 10, 20, 30, 131. Well, can I make this a different way? Sure, I could take a stack off, and then how many ones do I have to add? I have to add 10 ones. So I could make it this way. I could take a stack off, and I could have 100, 2 stacks, and 11 ones. What if I take the 100 off? Then I need to add 10 stacks, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have to add 10 stacks, because these 10 stacks equal this 100 that I just took away. So I'm taking the 100 away, and I can add these 10 stacks, and I still have 131. It just looks different. And mine doesn't even fit right here, does it? Okay. So today we are going to use this is a different page in your math book. It's not in the big math book. It's in that tiny pink math book that I sent home that says Indiana, or it might say IN, I can't remember. But you need to find that math book, and it's 10A, okay, 10A at the tippy top, okay? So you might want to press pause until you find that math book if you don't have it, and we're going to get started together. All right. It says that Emily needs 235 toy blocks to build a castle. The toy store sells the blocks in 3 different kinds of packages. Emily can buy boxes of 100 blocks, stacks of 10 blocks, or single blocks. How can she buy exactly 235 blocks in the largest packages possible? Okay, so if we were going to do it quickly, we know if she needs 235, I would need 2 hundreds, 3 tens, and 5 ones, right? I need that. So I would need 235 is 2 boxes, so write a 2 there, 3 stacks, so you're going to write a 3 there, and 5 single blocks. So Emily can buy 2 boxes of 100, 3 stacks of 10, and 5 single blocks, because that's what we drew. That's what they already did this one for us. They already drew that one for us, right? Okay. But here's what this is now what we're going to do here is it says, suppose the toy store has no boxes of 100 blocks. What's another way that Emily can buy 235 blocks? Well, let's go to our tens and ones box. If she had 235, but they didn't have any hundreds. They didn't have this 100 and they didn't have this 100. How many stacks am I going to have to add? So I'm going to have to add 10 stacks for this 100 and 10 stacks for this 100. So I'm going to have to add 20 stacks in there. I don't even have 20 stacks, but good thing the toy store does. Okay, so in this section right here, we're going to write our answers. So Emily has, ready? Let me move this over for a second. She'd need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the first 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the second 100. That's 100, 200. Now she needs 30. 1, 2, 3, 30, and then 5. 1, 2, 3, 4, 5. So Emily would need 10, 20, 21, 22, 23, 23 stacks, and 5 single blocks. Okay. So Emily can buy 235 blocks as 23 stacks and 5 single blocks. Okay, all we did was take that 235 from here and we traded those 200s for 10s. 10 for this 100 and 10 for this 100. So we added 20 tens, 20 stacks as our book calls them. Okay? All right. So you are going to work on this one. This is another problem, but similar to the last. Oops, my marker went through my page. Sorry about that. Similar to the last. And it says Elton needs 123 blocks to build a tower. The toy chest store sells blocks in boxes of 100, in stacks of 10, and as single blocks. Find all the way Elton can buy 123 blocks. Make a list of all the boxes, stacks, and single blocks that equal 123 blocks. Okay, so we're going to make a chart. You're going to fill in the chart. And we are going to look and see how many boxes of 100, how many stacks of 10, or single blocks we need to make 123. Okay? In every single row, you'll notice one number is missing. So we only have to find out one number. They give us 2 and we have to find the third number. Okay, so for example, in this first row, it says If I have 3 single blocks and 2 stacks of 10, how many boxes of 100 do I need to get to 123? If I have 3 single blocks, I have 3. If I have 2 stacks of 10, I have 20, so it's 23. So how many hundreds do I need to get to 123? I just need 1, right? All right, row 2. I have 1 box of 100. I have 1 stack of 10. So look, instead of 2 stacks of 10, I now have 1. So how many single blocks do I need to get to 123? I have 110. So I traded, I took 1 stack away, so I'm going to have to add 10 over here. So instead of 3 single blocks, I need 13. Okay, now I still have 100, so that's 100. And I have 23 single blocks. So how many stacks of 10? I need 0 stacks of 10, 0 stacks of 10. All right, I'm gonna do this because these 3 kind of go together and then the rest of them go together. All right? Okay, ready? I have 3 single blocks, that's 3. I have 12 stacks of 10, 12 stacks of 10. 12 stacks of 10 would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So I have 123. Do I need any boxes of 100? Nope. And if you're like everybody in the class, you're going to notice there's zeros all the way down. All right. Now if I have 0 boxes of 100 and I have 11 stacks of 10. Now I took 1 10 away. I used to have 12. Now I have 11. How many single blocks do I need? 13. I need to add 10 single blocks. All right. You are going to be finishing this page. You're going to be using your 10s and 1s blocks, and you can see if you can find a pattern, because at the very end you're going to ask, what pattern do you see in this list? All right, take your time, go through it really carefully and make sure every single row you have 123 blocks that Elton needs for his tower. Have fun!